What conditions must exist for a quadrilateral to be a parallelogram? So we're looking at the conditions of parallelograms today. Your essential question is, how do I determine if a quadrilateral is a parallelogram? Your learning intention. I'm learning to use the conditions of parallelograms to determine if a figure is a parallelogram. So we've got this warm-up question. Pause the video and see if you can do the warm-up question on your own. The one thing that we went through last class period that you have to know, what is the sum of the interior angles of a quadrilateral? If you cannot remember the degree measure of those interior angles, think of a square or a rectangle. Those are quadrilaterals. Each of the angles are right angles. So you would have 90 degrees times 4 angles would give you 360 degrees. So we know that the sum of all these angles is 360 degrees. Pause the video and see if you can figure out the measure of angle D. Okay, as I'm looking at this, I want to find the measure of angle D. So I am going to call the measure of angle D X, because that's my unknown variable. So the measure of angle C is 2 times. So the measure of angle C will be 2x Okay, what about the measure of angle B? The measure of angle B is 2 times the measure of angle C. So the measure of angle B will be 4x, because that's 2 times C. And then finally, the measure of angle A will also be 2x. So look, those are all the different angle measures. We have to add them all together to get our total. So let's get started. X plus 2x plus 4x plus 2x is equal to 360 degrees. You add all those angle measures up and it is equal to 360 degrees. So 1 plus 2 is 3, 3 plus 4 is 7, plus 2 more is 9. 9x is equal to 360 degrees. Divide by 9. And x is equal to 40 degrees. I almost said 90 degrees, but that would not be right. 40 degrees. So if we're looking at D, this is 40 degrees. C and A are 2 times 40 degrees, so these would be 80 degrees. And then the rest would be angle B. So we've got 40, we've got 160, that gives me 200. 360 minus 200 is 160 degrees, or 4 times 40 is also 160 degrees. So you're able to find all those pieces by setting up your equation. So what are the conditions to be a parallelogram? First condition, if it is a parallelogram, then the opposite sides are what? Congruent is correct. You can always use the symbol for congruent. If it is a parallelogram, then opposite angles are also congruent. But what if they are consecutive? They could be congruent, but more than likely they're not going to be congruent. They're going to be supplementary. Remember when we did the parallel lines cut by a transversal? Your same side interior angles are supplementary. Okay, now, yesterday we actually did the last class period, we did the proof of the next one. If it is a parallelogram, then the diagonals do what? They bisect each other. Okay, so for the next one, if one pair of opposite sides of a quadrilateral are something and something, the quadrilateral is a parallelogram. So the parallelogram goes here. What do we know about opposite sides? They are congruent and parallel. Or parallel and congruent, but it has to be the same thing. Okay, converse of the conditions that we just went through. We're switching it around. So if we're looking at, if opposite sides we go up here, they have to be congruent, then you have a parallelogram. If opposite sides of a quadrilateral are congruent, then the figure is a parallelogram. If opposite angles of a quadrilateral are what? Then the figure is a parallelogram. Opposite angles have to be congruent. Okay. If the consecutive angles of a quadrilateral are what? Supplementary. Then the figure is a parallelogram. And for the last one, what did the diagonals do? Well, they have to bisect each other. And if they bisect each other, then it is a parallelogram. Remember, that is the picture of a parallelogram. Okay, so we're going to start looking and thinking, okay, can I state it is a parallelogram? On the first ones, what do we know about opposite sides? The opposite sides are congruent. That's a theorem that proves it. Okay, so we know these two sides are 15. We don't know what these two are, but that tick mark tells us that they are congruent. Opposite sides are congruent. You now have a parallelogram. What about the next one? Do we know anything about the sides? No. What do we notice about the diagonals? This is 12, this is 12. That's bisect. This is some length, this is the same length. So the diagonals bisect each other. If you have any questions, back up and listen to the first part of the video again. This is all ideas that you need to be able to remember and use. These are your conditions. Okay, now, how do we use this? Find the values of the variable that will make the figure into a parallelogram. So if we're looking at an x and y, they're parts of my what? They are parts of my diagonals. What do we know about the diagonals? The diagonals bisect. Bisect means cut evenly in half. So I know that x plus 5, if I'm looking at the first diagonal, here's my diagonal. The two pieces have to be the same. X plus 5 equals 12. I'm going to subtract 5 from both sides. And x equals 7. Same thing's going to happen with my y. $19 equals 3y minus 2. You start by adding 2 to both sides. $21 equals 3y. Divide by 3. And 7 equals y too. So when x and 7 are both y's, you know you've got a parallelogram. Okay, for the next one, we know that opposite angles are what? They are congruent. So I know that 2x is going to be equal to 120. So divide both sides by 2. And x will be equal to 60 degrees. What about y? Those are your opposite sides. Opposite angles, I mean. Opposite angles are what? Congruent. So y is simply equal to 60 degrees. Okay, any questions on those two types of problems? Okay. The brackets that support a basketball hoop can be modeled after KLMN. For what values of x and y is KLMN a parallelogram? Opposite sides of a parallelogram are what? Parallel and congruent. So thinking about that, I know that my two x values, those two expressions have to be equal. So x plus 4 is equal to 3x minus 12. Start by subtracting x from both sides. 4 is equal to 2x minus 12. Add 12 to both sides. 4 plus 12 is 16, which is equal to 2x. Last step is to divide by 2, and x is equal to 8. On the first one, x and y were the same amount, or same number. Do you think it's going to happen again? We'll see if they're that talented with their problems. So looking at the other problems, I'm going to look at 7y is equal to 5y plus 6. I am going to subtract 5y from both sides. 2y is equal to 6. Last step, divide by 2, and y is equal to 3. So if I'm looking at this, 7 times 3 is 21. That side would be 21, and the other side would be 21. X is 8. 8 plus 4 is 12. The other side would be 12 also. Any questions? Okay, the slopes of the sides of quadrilateral or QRST are shown below. Can you conclude that QRST is a parallelogram? Explain. Okay, so the first thing we're going to do is to draw this figure. Okay, so this would be QRST. If you notice, your numbers have to go in in the same order. QRST. I could have also done QRST going backwards, but they still have to be the same order. So I know that QR, the slope up here is -1/3. For ST, the slope is, or -3. I got that wrong. -3, not -1/3. I combined the two slopes. So are those two lines parallel? Yes. For the other two, your slope is 1/2. Are those two lines parallel? Yes. Opposite sides. Are parallel. So, QRST is a parallelogram. Yes. How do you know when you're successful? When you can use the conditions of parallelograms to determine if that quadrilateral is a parallelogram. So this is applying the conditions to be a parallelogram.